Hi applied math students, welcome to our channel Max Plus U. Successfully we have completed 4 exercise in unit 3A differentiation and its application children. So 5th exercise basic concept local maxima and local minima we are doing. Here we have two tests, first derivative test and second derivative test. We can do in any way. I am going to explain and I am going to do with the second derivative test. Okay. So what is second derivative test? Second derivative, the name itself you have to differentiate 2 times. Okay. Let f be a function defined on an open interval. Okay. Open interval a comma b. Let f be a continuous at a critical point. Critical point C belongs to open interval a comma b. So how we have done in increasing decreasing children, same way you want to find the critical point. How you will find the critical point, I hope you all remember. One time you have to differentiate, equate with 0 and get the x value. F dash of x equal to 0 and get the x value. Am I correct? So the point C is called the point of local minimum if f dash of C equals 0, as I said, and f double dash of C greater than 0. So you are differentiating 2 times and you applied the critical point, you got greater than 0 now, it's minimum. Sir, greater than 0 now, maxima only no sir, greater value no sir. If you got greater than 0, okay, so the positive value in double time differentiation, that means second order derivative, 2 times you differentiated and you got positive value now, it is minimum. Understood what I'm talking? And we say that f of c is a local minimum value of f of x. So 2 time differentiating less than 0 na, that is what minimum. So 2 time differentiation and applied the critical point and you got less than 0 na, that means you got negative value na, then it is local maximum. So that f of c, that critical point you applied na, what you are getting, that is the local maximum value of f of x. So simply greater than 0 is minimum and less than 0 is maximum. Hopefully you may understand. This is for second time differentiation. It is what second order derivative. Okay, unit 3A differentiation and its application. Why sir now unit 3A like that you are mentioning na? Next unit 3B, unit 3C and all is there. There also XII 3.1, 3.2 only. So that time you have to be clear no? So unit 3A differentiation and its application like that separately we have a playlist. Kindly check that playlist only, this videos and all is there. Clear? Okay, unit 3A differentiation and its application XI 3.5. As I already said, successfully we have completed 4 exercise. The last exercise in this unit 3A. Happy no? I am also happy. Find the local maxima, local minima, local minimum value and local maximum value. Okay, what do you have to do? What you have to do na? Till now what and all basics we have done, that we are going to follow. Good news is how the f of x is there, you see children. How much easy. Like that easily given na, x square differentiation 2x. Exactly. For doing f dash of x. Differentiate with respect to x. Minus 6 x differentiation na 1. Constant separately is there na, differentiation 0. So f dash of x is 2x minus 6. Sir, x differentiation 1, constant differentiation 0. This and all you don't know. Can we write directly this? Exactly. You can write directly. But how 16 went, how 6x becomes 6 like that we should not have. So I am written. Suppose this video only are doing seeing first. That time you should not have any doubt. For that time doing it, you can directly write this step. Then as usual f dash of x equal to 0. Why? Even increasing decreasing we have done that same thing. Okay? But this is not increasing decreasing. This we are doing local maximum local minimum. Okay. 2x minus 6 equal to 0. Minus 6 goes that sign of plus 6. X equal to 6 by 2. Get the value x equal to 3. So this 3 directly we will go for the taking the intervals in increasing decreasing. But here if you don't want to talk about the intervals, directly go for second derivative test, that is nothing but 2 time differentiation. What's that 2 time differentiation? Already you have 1 time differentiation 2x minus 6 that you differentiate again. 2 another time differentiation x differentiation 1, constant differentiation 0. So I will get to 2. What you will do? Yes, I will get 2 that 2 you write. Okay. F dash of x is 2 greater than 0. Sir, f dash of x 2 greater than 0. Okay. Instead of x 3 you are applying, again you are 2 writing. Why? Actually, you just understand one logic. If 2x, like that x term is there now only we can apply the 3. Correct? 2 into 3, 6 go. Like that we can write. It is already constant. Then why sir you are applying it now? That is just like a rule. Okay, so you have to understand the rule. You are differentiating 2 times and apply the critical point in it and you are getting it. Sir, here we can't apply itself. We got only constant. That is not your error. If question itself wrong, okay, you can't write. For that, the what board said, no, we won't give 5 mark. Now, how it is correct? Question wrong, you have attended, na? They are supposed to give full mark. La? Same way, here 3 you can't apply. That is not your error, their error. So that means here it's not possibility, but you have to write f dash double dash of 3 and write 2 greater than 0. Okay, suppose f double dash of x itself I didn't write this step. Any chance of reducing mark is there, Asan? Yes. Okay, I hope you may understand when I'm talking about the basics. What I have said now, you have to apply the point f dash of c and f of c. So double dash, yeah, when you're applying f double dash of c only less than 0, not f double dash of x. So the critical point we should apply. Okay, so you should mention the critical point 3 in it and again write to 2. Copy paste I'm going to do. That's it, nothing else. So 3 is the point of local minima. Sir, greater, sir, maxima, sir, don't say. Here greater than 0, it's nothing but minima. So local minima. Fix it. Local minimum value. Apply, children. 3 square minus 6 into 3 plus 16. 3 square 9. 6 3s are 18. 16. So 9 and 16 add 25. 25 minus 18 is nothing but 7. So 7 is clear. Check, that is nothing but local minimum value. Okay, local minimum value you are finding now. Where local maximum value? It's not that you're going to find single question both. You may have local maxima, you may have local minima. Which you are getting, that you're going to find. Did you understand? So if it is some is like a cubic equations or you have a biquadratic equation, you may get both also. But here you have only local minima alone. Did you understand what I'm talking? Suppose you got 2 points. I applied here 3 and I got here greater than 0. Suppose I applied here and there is some negative value and you got less than 0, you will get both. Since we have got only greater than 0, we have only local minima. So that local minima value what na? I think we have done in the, we have saw in the notes, f of c is the local maximum value or local minimum value. I think now we are talking about local minimum value, correct? So f of c we going to find it. Okay, apply pa. Instead of that c only, that 3 critical point we have applied and we got the answer. Second subdivision what, sir? Like that you asked, na? Log x by x. Same way, x greater than 0 they said. So apply quotient rule. U is log x, b is x, then log x differentiation 1 by x, x differentiation 1. We all know quotient rule, u by v the whole dash equals u dash v minus v dash u divided by v square. Start applying, children. So we are getting like this, x cancel and I got 1. Then 1 into log x is log x divided by x square. As usual, put f dash of x equals to 0. Till this is clear, check. Then division x square goes inside, na? 0 into x square, 0. So I got, we got 1 minus log x equal to 0. That is nothing but log x equal to 1. Or minus log x goes inside, na? Plus log x, 1 equal to log x. We all know 1 is nothing but log e also. 1 equals to log e. So instead of 1 log e applied, na? Log removed and we are getting the value as x is e. Suppose they have asked only critical point, sum is over. E is a critical point like that. F dash of x, we already know. So that we going to differentiate again. Why, sir? Differentiating again, na? We have to use the local maxima or local minima that we going to find. So differentiate with respect to x. U is 1 minus log x, b is x square, 1 differentiation 0, then minus log x differentiation 1 by x square differentiation 2x. I hope these all we have done more time. U by v the whole dash, u dash v minus v dash u by v square. Then I have to cancel the x and x after applying u dash v minus v dash u. I hope you are clear what I have applied. Okay, just check. Then any changes is there, you inform. Then I have multiplied distributive property minus 2x plus 2x log x. Have kept inside. So minus x minus 2x, if I mingled, I have got minus 3x. You can, without adding it also, you can take something common and you can divide. That is all your wish. After doing it, I take an x as common. Simplifying, children, nothing. Then end x and x power form gets cancelled and I getting the value. This you can do your own simplification, you may get any other things. It's without adding also you may do it. And apply, ultimately apply x equal to e. So what are you going to do? Like that you asked, na? Instead of fx, we have applied. Last sum, we don't want to apply itself because it was very clear. But here, the x value, we were supposed to apply e. Because here x term was there, last term x, the value is, the x variable itself not there. So 2 ones are 2. So we all know minus 3 plus 2 is minus 1. Children, actually, the answer want to write like that, no necessary. If you are able to say it is less than 0, once negative comes na itself, we can write it as less than 0. Since it's a less than 0, it's a local maxima. So E is a point of local maxima. I wanted to find local maximum value now. F of x I should substitute. We all know f of x in the question is nothing but log x by x. So log x by x we are substituting. So log, instead of x we are applying e, then again instead of x e. So log e value we all know 1. So 1 by e is the answer. Kindly forward this video to applied maths friends. It will be useful for them. Thank you.